Hi everyone. Today I am reviewing a 2025 paper that asks a pretty simple question. What if we replace NPC behavior trees with a large language model and a personality slider? This paper is by Tarigan and colleagues at University of Sumatera Utara in Indonesia. Let's start with the problem. When we need to build our ECS engines in this course, if we need one NPC to make decisions, I think most of us will consider a finite state machine or a behavior tree. This work because they are predictable, they are testable, and they slot cleanly into an ECS system. But the predictability is also the problem. Once a player has seen the tree fire a few times, the NPC feels like a puppet on rails. And if you want more than one NPC with different personalities, you basically end up authoring two different trees. There is no clean personality dial in a behavior tree. The five sliders come from psychology, the ocean model, which is also called the Big Five: openness, conscientiousness, extroversion, agreeableness, neuroticism. Each is a value between 0 and 1. The idea is instead of writing a behavior tree, you set five numbers. The LLM reads the number along with the current game state and picks what the NPC does next. The player can even open a settings menu mid-game and retune the NPC's personality with sliders. This is a pitch and let's see how it works actually. They actually built a test game called Runeterra. It's a 3D third-person hack and slash roguelike RPG. Anime character with a sword, procedural levels, two enemy types, a boss at the end, of course. The player has a companion NPC that follows them around. In combat, that companion picks one of the seven predefined actions. Like you can see here, focus on one target, attack the nearest enemy, count, and behaviors like those. Here's the system architecture. Five modules, and if you take a look at it, it looks a lot like ECS. You have memory module that stores past events, and environment module that does vision-based enemy detection with a 150-degree cone. A state module that is actually a tiny FSM with two states, combat and wavering, and one action module in the middle that acts as a prompt generator. The LOM itself sits outside. They use Gemini Pro through a REST API. Um, so every decision cycle, the action module pulls data from memory, state, and environment modules. And they build a text prompt, later send it to Gemini, parse the JSON response, and update the state module with the chosen action. So the prompt is the central artifact. Let's look how it's built. Every prompt has six sections. First, context, a fixed game description that tells the LLM what Runeterra is and what enemies exist and what role the companion plays. This part is identical every frame, not every frame, every request. Second, personality, the five ocean values as numbers. Third, the summary, the companion's current state and what happened as a result of the last action. Fourth, recent actions, the three most recent events pulled from short-term memory. Fifth, player and NPC status, health, position, that kind of thing. Six, response templates, instructions telling the LLM. It returns JSON in the schema and picks exactly one of the seven actions. And this is very important because it's how they turned an open-ended language model into a constrained decision maker. So one important insight, the LLM as decision selector, because it does not generate arbitrary behavior, it does not invent new actions, it does not write code. It only picks one of the 7 predefined action IDs and fills in a target parameter. So the output is a JSON object, the action ID, a target if the action is one, and a short justification. Quick note on memory. Since the LLM is stateless, they have to feed context in every request. Short-term memory is just the 3 most recent events. Long-term memory is different. They use the LLM to generate one-sentence summaries of the past scenes. Um, and those summaries stack up. To keep the prompt from growing forever, each memory has recency value that decays by multiplying by zero point 0.9 every cycle. Anything below 0.25 get deleted. That's the only equation in the whole paper, and it's not complicated. Now, result. So they defined 4 archetypes: protector, leader, rogue, wildcard, each with a specific ocean profile. Then they played through and counted which of the 7 actions the LLM picked. The protector chose taunt and tank 42% of the time. The leader chose focus fire 42% of the time. The rogue chose focus fire 58% of the time and attack nearest for 37%. Very aggressive, basically zero defense, and the wild card was distributed roughly evenly across actions, which is what you expect from a chaotic personality. So the sliders do measurably affect behavior, the system works. One more thing before we look at how players feel about it, personality does not just change which action the NPC picks, it also changes how NPC talks. For example, the protector says, partner, I'll deal with the nearest enemies, stay back. Second test, 8 RPG players played this game and filled out 6 question survey, and the highest scoring question was this could be a feature in commercial games at 4.37 out of 5. Responsiveness and behavior context alignment both scored around 4. Sample size of 8 is definitely too small. You cannot draw strong statistical conclusion, but the direction is positive. Limitations also include the LLM latency because it's inconsistent and sometimes very noticeable in real-time combat. They had to add fallback behaviors just to bridge that lag. Um, and also, the AI has quotas that limits concurrent users, and only 7 predefined actions definitely not enough. And also there is no like head-to-head comparison with a traditional behavior tree and things like that. Now, my take, connection to our course, there are 5 modules, map cleanly to ECS, memory, state, and component, environment or components. The action module is a system that runs each decision cycle and dispatches to the LLM. Do we consider adding this to our engine? Probably not for real-time combat. The latency is a killer, and paying a per request API cost for every NPC decision does not scale. But for something turn-based dialogue trees, quest giver NPCs, strategic advisors, this approach could be really attractive. One last thing before we finish, this idea has already shipped as a real product. There is one Chinese indie game on Steam, and which is called Historical Simulator, 重真. Quick caveat, it's on Chinese Steam only, so you cannot grab it from a US account or from like US IP probably. But the design pattern is what matters. You play the last emperor for Ming Dynasty, and every historical minister you talk to is a LLM-driven character with personality and memory. It's basically this paper system deployed at scale. Two things they solved that this paper does not. First, it's turn-based, so the latency issue the paper says doesn't matter here. Second, they made cost visible. The base game is free. You get 1,500 free tokens to start. After that, you buy tokens or you plug in your own LLM API key. So, and if this business model gonna be successful, I think only time gonna tell us. And thanks for watching.